So we are now at lesson 15A, the video game diet. Consider the following research study. As we've done all semester, if you have not already looked at question 1, you need to go ahead and hit pause, read through question 1, write down some answers, and then come back and we'll walk through this together. There is a research question. Dr. Elizabeth Jackson, a professor at the University of Michigan Health System, surveyed 1,003 middle schoolers about their snacking habits and their predominant after-school activity, including outdoor activities, video games, or watching TV. There was a conclusion. Kids who spend the most of their time outdoors eat the fewest calories from unhealthy snacks. Interestingly, kids who played the most video games ate fewer calories from unhealthy snacks than those who tended to watch more TV. Question 1. In a statistical study, a variable is an observation that changes from individual to individual. And then part A says, so what are the two variables in this study? So one of the things that helps me the most is to go ahead and start thinking, what would be the independent and the dependent variables? Or what would be the why is that going crazy? What would be the explanatory variable and what would be the response variable? And then how to say it generic enough that it is specific enough to cover what's going on in the study. And so looking up here in the study, we are looking at middle schoolers and we see snacking habits and we see after-school activities. There are 3 listed. And then in conclusion, it was an outdoor activity. And then we get a little bit more information, calories from unhealthy snacks. So here on the explanatory, right here, after-school activity. Let's see if it would make sense if we put after-school activity here. And then over here, calories from unhealthy snacks. I think that's going to be specific yet generic enough that if we have the after-school activities, that would include outdoor, video, watching TV. And then over here, we're looking to see which one of these had the fewest calories from the unhealthy snacks. So as we have been looking at, especially in the last couple of lessons, make sure that you have the vocabulary understood with the nuances and the specificities of each one. Like this one says, in experimental studies, researchers manipulate the explanatory and observe the effects on a response. To manipulate the explanatory, they divide subjects, smaller groups, and apply a different treatment to each group. If the groups are truly similar, huge, highlight, underline, yellow, don't know what else I can do here, stars, neon signs. But the crux of this is, if the groups are truly similar, then the differences observed in the response variable might be attributed to the explanatory variable. So even though we get all excited that if it's really similar and we see some differences, we still have to be cautious on how we write our results. Determine when a study design allows a conclusion to be made about cause and effect, when we can say that, and then design an experimental study. So part B is identify the explanatory and the response variables in this study, and also classify them as categorical or quantitative. So we were saying that the explanatory is the type of after-school activity. And then the response, it's going to be the calories consumed from unhealthy snacks. And so the type of after-school activity is going to be categorical. The calories are going to be quantitative. Can researchers in the study conclude? Can they conclude that the amount of after-school activity was the cause for the number of calories that kids consumed from unhealthy snacks? Can you offer a possible alternate explanation? The answer is no. It may be that children who choose to watch a lot of TV had things in common with the kids who ate more calories and snacks. Maybe there was less parental intervention that caused both of these variables to increase together. Another piece of information, highlight, underline, put neon signs around it. In an observational study, researchers simply observe the variables of interest. However, in an experimental study, they are going to actively manipulate the explanatory variable. So back at our very first screen together in this lesson, right here it says that in this study, the professor surveyed. That is an observation. That is talking to middle schoolers. It is not manipulating where you have an experiment where you have a control group and a treatment group. It's simply observational. We are not allowed to say cause and effect. So part D is asking, was this an observational or an experimental? And as we noted, the survey is meaning it's observational. Justify your answer. It was a survey. Nothing was manipulated to cause or have or be or define as an experimental study. Part E, in what type of study can we make conclusions about cause and effect? And that would be right here. Experimental is the one where we get to say cause and effect with some other caveats on making sure that we have our ducks in order, if you will, on the study. So question 2, if you haven't already completed it, hit pause, go ahead and answer question 2, and even go back and look at parts or pieces and parts on question 1 if things are a bit fuzzy, because you want to fully understand what an observational study is and how you can talk about the conclusions, so that now when we get to part 2 or question 2, when they say let's redesign the study and let's make it into an experimental study to see if we can have a cause and effect conclusion. Now make sure you've done part or question 2, all of its parts, and then come back and let's walk through them together. Part A. The explanatory variable is the after-school activity. In an experimental study, should the kids or the participants pick an activity according to their preference, or should the researchers control this? Well, a well-designed study means that the researchers are going to control this. The researchers are trying to take out bias and error, and so one of the things they can do to start to ensure this is that the researchers control who will be in each of the groups. Part B. What does it mean in this context to say the researchers manipulate the explanatory variable in an experiment? Well, it means that the researchers are going to determine each student's activity. Like some could be playing outside doing one thing, some could be playing inside doing one thing and inside doing another. And whatever variables they want to look at, they are going to manipulate and assign. Part C, in an experimental study, The values of the explanatory variable are called treatments. So what are the treatments in this study? We're going to keep what they originally had in the study, where we have some outdoor activities. We have playing video games, and we have watching TV. And even as we're writing these down, I hope your brain is starting to question, well, what kind of outdoor activities? How rigorous of the activities? Will there be limits on what's going on, or maximums, minimums? And what about video games? Will this be sedentary video games or active video games? Start asking a lot of questions, because those can play into what should be in the study and or whether it was a good study in the end. Continue to process and think through our experimental study. Suppose you decide to apply the treatments to different groups by dividing children randomly, big word, among 3 groups. Would there be any reason to think that one group would be very different from another? And the big word is randomly. If we are creating the groups randomly, there is no reason to believe that they would be different. Part E. In an experiment, random assignment into groups tend to create groups that are similar. Another big word. The only real difference, big word, or big words, from group to group is going to be the explanatory variable that the researchers are manipulating. If the children assigned to the video group consumed fewer calories than the children assigned to the TV group, could there be another explanation other than the activity? And this is where I wish we had a live classroom, because this question usually gets some lively debate. But for the sake of our video, to answer the question, there is no other explanation other than chance variation in the random assignment into the groups. Again, write down your thoughts, write down your side comments. Please keep thinking and delving into a healthy paranoia about what we're doing in the assignment and what is going on. Part F. If the children in the video game group consume fewer calories than the children in the TV group, what conclusion can be made about the activity? And this is where the stars align, the heavens open up, and we get to say that we can conclude, if there are no other differences than the activity itself, then we can say that the activity was yes, we get to use the word, the cause of the differences in the caloric intake of the unhealthy snacks. Unhealthy snacks. Big smiley face, the world is amazing. But we keep talking. In experiments, if we apply the various treatments to groups that are similar in composition, again, well, if you can still see those words, that are similar in composition, huge words, similar in composition, then we can conclude that the treatment is going to be what's responsible for any differences that we note, observe, see, calculate in the response variable. I'm going to put a couple of stars around this one. It's worth noting, worth adding to a Google Doc, adding to flashcards, adding to something. Some final things to note about experimental studies. This is not in your set of pieces of pages, but something worth noting about experimental studies. In experimental studies, researchers are concerned about things that we were just talking about, the explanatory and the response variables. There is much focus on those 2 variables. For us to be able to say that there is or was a cause and effect conclusion, you or whoever are the researchers must divide the subjects into groups that are similar. We are trying to take all of the other variables out of the equation. And if we have similar groups and we're focused on the explanatory and response, we are going to be able to say we have a cause and effect situation. A little bit more, researchers are going to manipulate the explanatory variable by assigning a quantity of the variable to each of the similar groups. And it's going to depend on the study how many of those are, but they will be assigning one of those qualities to a group that is similar based on how many quantities that are in their study. And one final thought, if changes are present, if the changes are observed in our manipulation, if the changes are observed in the response variable, if they're observed in the response variable, then we can assume that the values of the explanatory variable are the cause. Why is the response variable the way it is? Well, because of the explanatory variable. This concludes our lesson 15A. You need to look at your syllabus to see if you have more lessons for this week. If you do, let's keep going. If you don't, do a happy dance, and I'll see you next week.